Welcome to SS2 Technical Drawing, Term 2, Week 3. So far in SS2, we have studied advanced geometrical drawing techniques, descriptive geometry, intersections, truncated solids, and surface development. Now we shift to engineering drawing practice, the standards, conventions, and types of drawings used in engineering and manufacturing. Today we focus on assembly drawings, the drawings that show how parts fit together to form a complete machine or structure. Every manufactured product, from a bicycle to a bridge, begins as an engineering drawing. Understanding assembly drawings is essential for anyone who wants to work in engineering, manufacturing, or construction in Nigeria. An assembly drawing shows how two or more parts are assembled together to form a complete unit. It does not show every detail of each individual part. That is the job of detailed drawings. Instead, the assembly drawing shows the positional relationships between parts, the sequence of assembly, and how the parts interact. Assembly drawings are used in several stages of the engineering process: during design, to check that all parts fit together; during manufacturing, to guide workers assembling the product; during maintenance, to show technicians how to disassemble and reassemble the product; and during procurement, to identify which spare parts are required. In WAEC technical drawing, students are often asked to draw an assembly of 2 or 3 simple parts, such as a nut and bolt, a cutter joint, a knuckle joint, or a simple bracket assembly, in orthographic projection. There are several types of assembly drawings. The general assembly drawing, sometimes called the GA drawing, shows the complete product fully assembled. It includes overall dimensions and part numbers referring to a part list. The subassembly drawing shows a group of components assembled together before they are added to the main assembly. For example, in a car engine, the cylinder head subassembly would be drawn separately before being assembled onto the engine block. The installation drawing shows how a product is installed in its final location, for example, how a water pump is connected to a pipeline and foundation bolts. The exploded assembly drawing shows each part separated from the others along the axis of assembly, so that the viewer can see all the parts and understand how they fit together. Exploded assembly drawings are commonly used in instruction manuals and spare parts catalogs. The outline assembly drawing shows only the outer shape of the assembled product, without internal details, used for packaging and transport purposes. Assembly drawings follow specific conventions that are different from detailed drawings. First, section views are widely used in assembly drawings to show internal features. A section view cuts through the assembly to reveal internal parts that would otherwise be hidden. In a section view, the cutting plane passes through solid material and the cut surfaces are shown with hatching. Different parts are hatched at different angles or with different spacing to distinguish them. By Nigerian Standards Organization and International Convention, adjacent parts are hatched at opposite angles, one part at 45 degrees to the right and the next part at 45 degrees to the left. Second, standard parts such as nuts, bolts, washers, pins, and shafts are not sectioned even when the cutting plane passes through them. This is because sectioning standard parts gives no additional information and makes the drawing confusing. Third, ball bearings, gear teeth, springs, and rivets also have special conventions. They are typically shown as simplified symbols rather than fully drawn. Fourth, all parts in an assembly drawing are given a part number, written inside a circle called a balloon or item bubble, connected to the part by a leader line. A parts list at the top or bottom of the drawing lists each item number, name, quantity, material, and standard reference. When reading an assembly drawing, follow these steps. Step 1. Read the title block. The title block gives the assembly name, drawing number, scale, date, draftsman name, and the company name. Step 2. Read the parts list. The parts list identifies all components by item number, name, quantity required, and material. Standard purchase parts such as bolts, bearings, and seals are listed with their standard designation. Step 3. Identify the views. Most assembly drawings use 2 or 3 orthographic views, sometimes with a section view. Step 4. Trace the location of each part. Use the balloon numbers in the drawing to find where each part is located. Step 5. Understand the section views. Identify which surfaces are sectioned, shown with hatching, and which are not, standard parts, shafts. Step 6. Read the overall dimensions and any critical assembly dimensions given. For WAEC, practice reading the assembly drawings of common mechanical components, the cutter joint, the sleeve and cutter joint, the knuckle joint, the flange coupling, and simple bearing arrangements. To summarize, an assembly drawing shows how parts fit together to form a complete unit. Types include general assembly, subassembly, installation, exploded assembly, and outline assembly. Key conventions: section views show internal parts with hatching, adjacent parts are hatched at opposite angles, standard parts such as bolts and shafts are not sectioned, all parts are numbered with balloons referring to a parts list. Reading an assembly drawing, start with the title block and parts list, identify all views, trace each part by its balloon number, understand section views, and read the overall dimensions. For WAEC technical drawing, practice drawing simple assembly views of cutter joints, knuckle joints, and flange couplings in full orthographic section.